Now let's take a look at some practice problems dealing with systems of equations. This question says, Maya and Carlos purchased jackets and hats from a store. The price of each jacket purchased was the same and the price of each hat purchased was the same. Maya purchased 5 jackets and 3 hats for $124 and Carlos purchased 2 jackets and 4 hats for $98. Which of the following systems of linear equations represents a situation if x represents the price in dollars of each jacket and y represents the price in dollars of each hat? Okay, so we can write two equations here, right? The first equation is going to be using this information, 5 jackets and 3 hats for $124, right? So if we want to write an equation based on that, and we know that x represents the price in dollars of each jacket and y represents the price of each hat, and Maya bought 5 jackets and 3 hats for $124, so we can say 5 jackets and 3 hats for $124. And we know that jackets, the price per jacket is X and the price per hat is Y, right? So if she bought 5 jackets, then we're going to multiply that by X because that's going to give us the total cost. For example, if each jacket was $10 and she bought 5 jackets, the total amount of money that she spent on jackets would be 5 times 10 or 50, right? In this case, we don't know what the price is, we just know that it's represented by X. So 5 times X is the total amount of money that she spent on jackets. Same thing with hats. Hats is the price per hat is represented by Y. So if we want to know the total amount that she spent on hats, we would do 3 times Y, right? Again, for example, if the price per hat was $15, let's say, then Y would be 15, and we would do 3 times 15 equals 45, which means that she spent $45 in total on hats, right? She bought 3 hats for 15 each, so she spent $45 total on hats. But that's just an example. We don't know what the actual price is. And sorry, I multiplied these. We should be adding them because we're adding the price or we're adding the amount of money that she spent on jackets and the amount of money that she spent on hats, and that should equal $124 because that's the total amount that she spent on hats and jackets. So that's going to be our first equation. 5x plus 3y is equal to 124. Now, if we want to know our second one, we can see that Carlos purchased 2 jackets and 4 hats for $98. So 2 jackets and 4 hats for $98. We're going to do something similar as before. 2 jackets and 4 hats for $98. Okay, so again, we're going to do something similar. We know that the price per jacket is X, so I'm going to do 2X, and the price per hat is Y, so plus 4Y equals the total amount of money that you spent, which is $98. So that's going to be our second equation. 2X plus 4Y is equal to 98. So let's see if we can find that system. It looks like that's going to be A. So in this case, they're not actually asking us to solve the system, just, write the system of equations. So we don't have to, graph it or anything like that. This would just be our answer. If they were asking us for the price per jacket and the price per hat, then we could graph it and solve it. So let's say that we wanted to know the price per jacket and price per hat. Well, we can graph 5x plus 3y equals 124, and we can graph 2x plus 4y equals 98. This is going to give us the solution to the system of equations, and it's going to give us the price per hat and the price per jacket. So let's see if we can find that. You see that they intersect at this point, 14.42 comma 17.28. So the x value is 14.42 and the y value is 17.28. That means that the price per jacket, which was x, is $14.42, and the price per hat, which was y, is $17.28. But again, in this case, they weren't actually asking us to solve for that. We just need the system of equations. Okay. Okay, this one says the solution to the given system of equations is x comma y. What is the value of y? Okay, so again, you can solve this one algebraically or using Desmos. If you wanted to solve it algebraically, what you could do is solve it using elimination. So why don't we actually try that before we solve it graphically? So we have 5x plus 12 equals 3y, and 5x plus 6 equals y. So what we can do is, notice how we already have the same x coefficient, so it's pretty easy to subtract these two equations. 5x minus 5x is 0, that cancels out. 12 minus 6 is 6, and 3y minus y is equal to 2y, so 6 equals 2y. Divide both sides by 2, and y is equal to 3. So now we can go back to either one of these equations, plug in y equals 3, and solve for x. So I'll go to this equation, 5x plus 6 equals y. And I'll plug in y is equal to 3, so I get 5x plus 6 equals 3. Subtract both sides by 6, 5x equals negative 3. And divide both sides by 5, x is equal to negative 3 over 5. So our x value is negative 3 over 5, and our y value is 3. If you go back to our problem, they're asking for the value of y, so that's just going to be 3. And we can also solve this one using Desmos. I showed you elimination, but in general, if you're given just like a regular system of equations like this, without any twists to it, some of them will have like a twist or a trick to it, and we'll see one of those later. But if it's just like a normal system of linear equations, generally it's best to use Desmos. And the way that you do that is you just plot both equations in Desmos and you see where they intersect, right? So if I plot these two equations using Desmos, then you can see that they intersect at the point negative 0.6 comma 3. And the y value of that is going to be 3. So that would be our answer. Okay. This one says the solution to the given system of equations is a comma b. What is the value of 5a plus 4b? Okay, so in this one, I think we can still use Desmos. The only thing about this one is that we will have to make a small change, but we can still use Desmos. But first, actually, I think it would be best um, if we solve this one using elimination or substitution, just so that we can see that we can, also use that. In this case, we're not using x and y. We're using a and b, but it's going to be the same process. So we have 3 times 5a plus 2 times 4b equals 18, and negative 3 times 5a plus 2 times 4b equals 18. So I think we should just be able to subtract these two equations, or we can add them actually. If we add them, 3 times 5a minus 3 times 5a is equal to 0. And then 2 times 4b plus 2 times 4b, that would be 4 times 4b. And then 18 plus 18 is just 36. So if we solve this for 4b, you divide both sides by 4, you get 4b is equal to 9. And the reason why I'm not solving for b is because in both equations, they just have 4b, right? So I think it would be better if, and we're wanting to find 4b plus 5a, right? So I think it's better to just leave them as 4b and 5a. So now that I know that 4b is equal to 9, again, I'm not going to solve it completely for b. What I'll do is I'll take this equation here, and I'll plug in here, instead of 4b, I'll plug in 9. So I get 3 times 5a plus 2 times 9 is equal to 18. Now I get 3 times 5a plus 18 equals 18. Subtract both sides by 18. 3 times 5a equals 0. Divide both sides by 3, and 5a is equal to 0. So 5a equals 0, 4b equals 9. So 0 plus 9, right? 5a plus 4b. That's just going to be, 5a plus 4b. That's going to be 0 plus 9, or 9. So that should be our solution. And that's correct. So now let's see how we could solve this one using Desmos. It's going to be the exact same method. We're just going to plot both of these equations and see where they intersect. The only thing is that Desmos doesn't recognize variables other than x and y. So if you plot 5 and b, sorry, if you plot a and b, it's going to think of them as constants, and it'll give you a slider or something. So we don't want that. We want them to be treated as variables, right? So we're just going to, when we plot this in Desmos, we replace a with x and b with y. So if we see what happens when we do that, it's the exact same equations, but a has been replaced with x and b has been replaced with y. We can see that they intersect at the point 0, 2.25. So you might be, wondering, hey, why isn't it intersecting at, why isn't, like, if I add 0 plus 2.25, that's not equal to 9, right? So the reason why is because we're not asked to find a plus b, we're asked to find 5a plus 4b. So if the value of a is 0 and the value of b is 2.25, what we need to do is we would need to do 5 times 0 plus 4 times 2.25, and then we would get 9, right? Remember, a is equal to 0 and b is equal to 4.2, b is equal to 2.25, right? And when we, solve that equation, 5a plus 4b, we do end up getting 9. Okay. This one says, in the given system of equations, m is a constant. If the system has no solution, what is the value of m? So I would say in this case, it's not one that we can necessarily solve using Desmos. I think it would be better to solve this one algebraically. And the way that we're going to solve this is, let me write down the equations. We have 9x minus 12y is equal to 6y plus 18, and mx equals 2 minus 8y. So you might remember near the beginning of the lesson I mentioned that when a system of equations has no solution, those lines are parallel, right? Because when you have two parallel lines like this, they're just going to go on forever and they're actually never going to intersect, right? So a system of equations has no solution when the lines are parallel. So our goal is we need to know what value of m will make this system of equations, will make these two lines parallel to each other, all right? And one trick that you're going to have to remember and memorize on the SAT is that when two linear equations are parallel, their slopes are the same and the y-intercepts are different, okay? And the reason why that works is, let's say that we have these two parallel lines, right? Let's say I have this one and this one. Notice how these two lines they have the same slope, right? They're increasing at the exact same rate, but this guy started a little bit higher than this one, right? And because of that, the lower one, the one that started at the blue point, is never going to catch up to the one that started at the red point, because they have a constant rate of increase, right? The rate at which they're increasing is both the same for both of them, right? But this one started a little bit higher, and because of that, this one will never be able to catch up. All right, so just keep that in mind, that we want to have the same slope but a different y-intercept. So now let's actually get to this problem. If we're dealing with slopes and y-intercepts, it would be best if we convert both of these equations to slope-intercept form first. So I'm going to start with this one. I'm going to convert this to slope-intercept form. I think first I'll subtract both sides by 9x, and I get negative 12y is equal to 6y minus 9x plus 18. Now I'll subtract both sides by 6y, and I get negative 18y is equal to negative 9x plus 18. Now I'll divide both sides by negative 18 because I want to isolate my y. And on the left side, negative 18 divided by negative 18 just becomes 1, right? They cancel out. So I get y is equal to, and then over here, negative 9 divided by negative 18. So I can say negative 9 divided by negative 18x, right? And then 18 divided by negative 18 is just negative 1, right? And negative 9 divided by negative 18, well, the negatives cancel out, right? And 9 divided by 18 is just 1 over 2, right? So I get y is equal to 1 half x. That's going to be my uh, first equation in slope-intercept form. Now let's look at this one. Mx equals 2 minus 8y. And although m is a constant, we're just gonna, apply the same operations in the same way. We don't need to worry too much about that. So I think I'm gonna start off by subtracting both sides by 2, because remember, I want to isolate my y. So I end up getting mx minus 2 is equal to negative 8y. And I'm actually going to rewrite it as negative 8y equals mx minus 2. Now I'm going to divide both sides by negative 8 because I want to cancel out that negative 8. And that's going to give me y is equal to negative m over 8x, and then negative 2 divided by negative 8 is going to be positive 1 over 4. Remember that when you divide two negative numbers, the negative signs cancel out. So I get negative m over 8x plus 1 over 4. And remember, my first equation was 1 half x minus 1, right? So you can see that these two equations have different y-intercepts, so we have that part covered. And the slope of this first equation is negative m over 8. The slope of the second one is 1 half. And remember that for these two equations to be parallel and have no solutions, we want them to have the same slope but different y-intercepts. So they already have different y-intercepts. Now we just have to make sure that their slopes are the same. So I want negative m over 8 to equal 1 half, right? Same slope, different y-intercept. Well, if we solve this one for m, we can cross multiply, right? We get 2 times m is equal to 1 times negative 8, or 2m equals negative 8. Divide both sides by 2, and we get m is equal to negative 4. So if m equals negative 4, if you plug in m equals negative 4, then the slope just becomes positive 1 half, right? So that's what we want, right? We want our two slopes to be the same but different y-intercepts. And for that to happen, we want m to equal negative 4. So that's going to be our solution. Okay, and there really isn't, if you look over here, right, solving solving a problem like this using Desmos and similar problems is not ideal, and honestly I don't recommend it because there's a high chance of error. If you look at the solution here, right, it's saying plot both equations on separate rows and add a slider for m. A system of linear equations has no solutions when their graphs are parallel, and that happens when m equals negative 4. So you might think, what's the problem using Desmos? I can just plot these two equations. I can plot these two equations using Desmos, and then add a slider for m and just, mess around with the slider until I get these two equations as parallel, right? And we can see that that happens when m is equal to negative 4, right? And you might think, that's not so bad. Why can't I just use Desmos? The reason why is because you may think that a different value of m seems to make the lines parallel, but they actually intersect. So it's kind of hard to tell, just by looking at the Desmos graph, and you might think that the lines are parallel even when they're not, right? So, for example, if I use m is equal to negative 4.1, this appears to be parallel, right? But actually, if I go down here, all the way down here, they do intersect, right? So it's not like a foolproof method, and it's prone to mistakes. So for these types of problems, it's best to just solve them algebraically. You can, verify using Desmos that when m is equal to negative 4, the lines do appear to be parallel, but I wouldn't rely just solely on that. Okay. Last problem, given that one equation in a system is y is equal to negative 4x plus 1, which second equation could result in a system with no solution? Well, remember that we want another equation, we want our other equation to have the exact same slope but a different y-intercept. So if we look at these solutions, this one has the same slope but also the same y-intercept. So this is actually the exact same equation, right? So we're not going to go with that one. We would actually go with C in this case because this equation has the same slope but the y-intercept is different. So if we were to plot these, then you would see that they are going to be parallel and there's no solution. And you can see that if you wanted to solve this one using Desmos, what you could do is you plot your original equation y is equal to negative 4x plus 1, and then you plot every single one of these equations, and you see which one causes, you see which one causes the lines to be parallel, right? So you can see that I've plotted this original equation in blue, right? And then these are A, B, C, D, right? These are the answer choices, right? Now, if I go with this first one, we can see that this answer choice A definitely does not cause the system to have no solution. They have a solution when they intersect over here, right? Answer choice B causes the lines to overlap, right? They're the exact same equation, so they overlap and they have infinite solutions. That's not it. Answer choice C does appear to be parallel with the original one, so that one is promising. And answer choice D does intersect. So um, answer choice D is not going to be correct, and the correct one is going to be answer choice C because it causes them to have no solution. So this one, it's not as bad if you use Desmos, but honestly, it's much faster if you just know the trick to parallel lines and no solutions. You can immediately find the answer that way.